Now, to get started, my name is Bill Winston. I'm a member of the data services team in Olin Library, and I'll be talking to you today about GIS and ArcMap. But first, I wanted to take a quick moment and introduce the rest of the team. Jennifer Moore, Dr. Doris Scott, Molly Webb, and myself, we all comprise the data services team, and our emails are listed here, but you can find us on gis.woostel.edu, and that's our home web page. And so the data services team is part of the university libraries, and we help students, faculty, and actually staff as well manage, analyze, visualize, share, and preserve data. The way we like to look at it, as many data sets come in a rather disorganized fashion. And our job is to help you understand how to reorganize that data into a format that's more usable, preservable, and hopefully helps you do your jobs a little bit better. So the outline today for the session, I'm going to start by basically covering a little bit of information about what GIS is, how does it differ from CAD or Adobe Illustrator. I'll talk a little bit about GIS data sources, and then we'll be doing a hands-on demonstration where I will walk through utilizing the ArcMap application to perform various functions. And I'll show you basically how to deal with bringing data in, symbolizing it, working with it in various ways, and then creating an actual map product that you can export from the software, either to use as a formal document, like in PDF format, or to embed into another application like Adobe Illustrator. I know that a lot of our architecture students are working in that for their final products, and I'll show you how to get information out of ArcGIS and into that platform. Then I'll talk briefly about a few resources that are available to you, and I'm going to try and leave about 10 minutes at the end so that we can cover some questions and answers that may not come up during the session. So with that in mind, let's get started. So GIS stands for Geographic Information Systems, and this is basically a set of data, tools, and workflows, and specifically software applications that help you work with that spatial data. Now, GIS has a wide range of applications in many fields, and I like to think that GIS is a cross-cutting discipline, much like word processing and spreadsheets are. When I was going to high school and an early college student, word processing and spreadsheets basically were the coin of the realm, so to speak, and you had to understand how to use those applications in order to survive in almost any discipline. And I'm beginning to think that GIS is now becoming one of those fundamental concepts and tools that we all need to understand in order to work better in our professions and in our daily lives. You've likely interacted with GIS in your phone when you use a routing application to try and find the nearest Starbucks or some other location that you're trying to go to. So GIS allows us to do various things, including mapping, some specifically spatial analysis, network modeling, like the routing example I just gave, and it allows us to work with vector data. Now, vector data refers to points, lines, and polygons, and we'll work with several different examples of those today. And it also refers to raster data. That's the imagery and the base map information that you might see in a lot of your applications. And it basically refers to a grid structure that has defined values at each one of the pixel points in that grid. If you have very dense pixels and they're made up of color symbology or color values, then you get an image that, if you zoom out far enough, begins to look like some of the images that we see on our screens. And GIS allows you to work with raster data as well. Now, one of the things that typically comes up when we're talking with architecture students is the difference between a GIS and computer-aided design or Adobe Illustrator applications. Now, the main difference is that with GIS, you have a defined geographic reference system. Now, that's not to say that CAD data doesn't have a geographic reference system, but CAD data is typically defined on a local coordinate system, whereby you're dealing with a site model with an origin of 0, 0 located somewhere on your site. And all of the other features and elements in your map might be referenced relative to that 0, 0 location. So you have Cartesian coordinates that define length and width and things like that, but they're all defined based on that 0, 0 coordinate. And if you were to take that sort of data and bring it in to a GIS and try to match it up with other spatial information, you would have difficulty because all of the origins would line up at the same 0, 0 location. And so although the buildings or the site plans may not be, maybe they're neighboring plans, but they would align because of that orientation, and you would get some overlap. Well, with GIS data, you typically have a global or projected coordinate system that's defined for your data. And it's intrinsically defined with real world coordinates that refer to real places on the ground. And so when you're dealing with GIS data, it's easy to bring such information into an application and have it align properly because it's all based on these global coordinate systems that basically accurately reference a more inclusive coordinate system and allows for these things to be aligned properly. We also deal with an accurate scale and spatial relationships between features. Another aspect of GIS that's rather important is the attribute information that comes along with features. Now, in a CAD system, you might see attributes such as line thickness or color. In a GIS, you're also going to get information about what that line represents. Is it a street? If it is a street, is it a paved street or a gravel street? You might also get information about what the name of the street is, what city is it located in, and if it's a segment of street, what are the addresses on the left and right hand sides from the beginning to the end of that section. So all of that ancillary information is called attribute information in GIS, and it helps us basically understand and model the real world in our digital space because we can pour information in there and basically store it and then allow us to use it for symbology or labeling or other purposes. In GIS, we can also define topological relationships. Features can fall within other features, and we can use topological relationships like finding things that are nearby. Maybe I want to find all of the buildings that are in 1,000 feet of another building or a street feature or something like that. And I'll show you an example of that later. And so this spatial topology or spatial relationships can be utilized in our GIS to query data sets and find out information and identify features that might be important to that particular question. In GIS, we can also build networks that model connectivity. So the routing example that I talked about earlier, where you use your phone to identify the fastest path between you and some destination location that you log in, that's all based on the idea of having a data set that defines the legal pathways between where you are now and where you want to go. And in most cases, that's a street network. And in GIS, we have those data sets and they have information associated with them like, is this street a one-way street? What is the speed limit on that street? So we can define a proper path that we would be able to follow to get to a location, and we can estimate how long it might take to get there based on speed limits and associated travel times. So lining up data is one of the most important things that we do in a GIS. And one thing I want to point out here, and I'll return to this idea later in the demonstration, is that your project will have a preferred coordinate system. And we can define that ourselves, or we can allow our data to define that for us. But your project itself will have a coordinate system, and each each layer of GIS data that you bring in will also have a defined coordinate system. And managing those is another important aspect of dealing with geospatial information. So the first thing we're actually going to do today is access some spatial information. Now, I know that many of you may have worked with geospatial information in the past, or you may be aware that you're able to download such things, but I'm going to demonstrate a couple of places that we're going to go and get some information. I'll show you a couple of slides here, and then I'm going to stop the slide deck and we're going to actually fire up a browser and go to these sites. So Great Rivers Greenway is actually the organization that is associated with the Hodiamont Tracks project that you guys are working on in your session, or this class. And they make some of their geospatial data available for use, and we're going to download an example of that data today to use in our map. Now, another site that we're going to visit is the city of St. Louis's open geodatabase, or open data portal, excuse me. And we're going to use that portal to actually access some parcel boundaries and some neighborhood boundaries that we'll use as polygons for example data sets. And then I know Petra shared with you a link to our geospatial data collection, which is a collection of local geospatial resources that the library has been compiling over time. And many of you have requested access to get to that. If you have already been, if your access has already been granted, you'll be able to follow along with that part of the session. Otherwise, once you do have access, you'll be able to repeat these steps later and gain access to that information. So I'm going to stop my show here, and I'm going to bring up a browser. And now bear with me just a second. I'm going to grab a couple of links. And place them in the chat. There's the Great Rivers Greenway site.
We are actually meeting them on Monday, Bill.
Oh, excellent. Yeah. And there's the St. Louis City website. So let's go to those first. And let me get on my browser here. Bear with me. I'm going to open that one up because it's in my clipboard. Whoops. Okay, so under the Great Rivers Greenway website, and you guys can see this, let me know if you can't. The Great Rivers Greenway, let me get to the, spread this a little bit so we can see it better. Under the About link, there is a link to resources and documents. And scroll down on that page, they have a link there to GIS Resources. I think I clicked too far. Bear with me just a second. Let me back up. Yeah, so in the public access portal and documents page, there's a link for data download. And that gives you access to many of the different data sets that they share. We're going to use this GRG GIS data.gdb. This is a geodatabase. And if you just click that, it will download a zipped file. And I'm going to, on my desktop, create a new folder. And I advise you guys to do the same. So create a folder, and I'm just going to call this Hodiamont. And then inside that folder, I'm going to create a new folder, and I'm going to call this source data. And then inside that folder, I'm going to store that geodatabase. It's a zipped file, and we'll come back later and expand that file. Now that's the only data set that we're going to get from the Great Rivers Greenway, because all of the shape files that you see in that lower list are actually part of the geodatabase that we're getting at the top. So I'm going to close this website and go to the open data for the city of St. Louis. And I want you to click on the all data sets link. Oh, I'm sorry, actually go back. We're going to click on the data by format link. And in the data by format, there's a shapefile link. And shapefiles and geodatabases are native GIS formats for storing information. Shapefiles basically have a single set of features in each shapefile. Geodatabases can actually store many different sets of features, all of them stored as individual feature classes. And we'll talk more about that in a moment. So on the data set page, there's a couple of things I want to download. First, find the parcel data link. And I'm just going to right click and open that in a new tab. And in that tab, we've got a list of the parcel data sets that are available from the city. And as you can see, they go back to 1997. And each year they've updated the parcel layer with a new set of features that correspond to not only modernizing the data set, but also changing it and making it more accurate. So scroll down to the bottom, there's a shapefile called current parcels. You want to click on that link to download the current parcel shapefile and store that inside your source data folder. You should see prcl_shape.zip and just save that file. And then I'm just going to go back, and underneath the current parcels entry, there is a parcel land records DBF file. The DBF is a tabular format, and this file goes alongside the parcel layer that we just downloaded, but it contains all of the property information, and we'll talk more about that later in the demonstration. So let's just download that DBF file and store that in the same place. And then we're going to go back to the shapefile datasets page and scroll down a little bit farther. At the bottom of the page, there's a ward and neighborhood boundaries option. So let's collect that one. And we're just going to go ahead and get the neighborhoods and wards shapefile. Download that and store it in your source data folder as well. Save that. Okay, now once those are stored in your local system, you now have your own copies of those data sets. And so that's an important concept. These are data sets you could now edit as you wish. So I'm going to minimize my browser, and on my desktop, I'm going to find the folder that I created.
Bill, do you think you could share that folder also on the chat box in case somebody didn't pick it up so quickly?
Yes, if you look at the beginning of the chat,
it's there.
Yeah, that box folder has everything in it.
Okay, perfect. Thank you so much.
You're welcome. It's got a source folder just like the one I'm creating now.
Okay.
And so if people have trouble downloading, they can just go there.
Okay, cool. Thank you.
Where is my new folder? There it is. So here on the desktop, I've got my Hodiamont folder, and I'll be working with that. In the file manager, I need to browse into the source data folder, and we've got all these zipped files. They need to be extracted. And so I'm just going to right click, and I use a package called 7-zip. If you've not dealt with compressing and decompressing files, that's beyond the scope of this exercise. I'm going to extract all of my files straight into this particular into the folder. So I'll use the extract here option, and I'm going to do that for each one. Whoops, actually that is a mistake on that first one. Apologies, we're going to need to undo that application. If you haven't done that yet, don't. The geodatabase actually needs to be stored inside a subfolder. And so, pardon me while I get rid of these files. And we'll start that over again. I'm going to get rid of all of those files that I just extracted. And for the geodatabase, I want to right click, and I'm going to extract it into a folder called GRG gisdata.gdb. Pardon me for that little mistake there. The geodatabase to your file manager looks like a folder, but inside of it is a lot of files that only the ArcGIS application will understand. And we'll talk about that here in a moment. Now for the other shape files, we can just right click and extract here. And we'll get a few extra files unloaded into our folder here. So I'm going to extract the par.zip, the neighborhood boundaries, or the NBR HDS underscore wards.zip, and then PRCL underscore shape.zip. All three of those should be extracted with the extract here option. Now, I'm not going to spend a lot of time on this, but I briefly wanted to mention and show you that there are several different files that have the same file name and a different extension. For this neighborhood boundaries set, for instance, there's 8 items here with the neighborhood underscore boundaries name and then a separate extension. All of these files together are considered a shape file, and it is important to keep these files together. So if you were to use a file manager to move things around, you want to make sure you move all of these files together, because if you don't, you can break the file and it won't work properly any longer. But these are all considered shape files. Now I'm going to open up this geodatabase folder and show you that inside it are a bunch of files that actually look meaningless. And to us they are, but to ArcGIS and to ArcMap, these make perfect sense. And so the thing you don't want to do is mess around with any files inside a .gdb folder. That will definitely mess up your data. So don't use your file manager to get in here. This should be the last time you actually come into that folder using your file manager. We'll look at that folder in a moment using ArcMap, and you'll see that it appears quite differently there. Okay, so I'm going to pause here just a moment. Did anybody have any questions regarding downloading and unzipping those files? And by your silence, I'm going to take that as an indication of that's a no. Excellent. Okay, so I'm going to actually just minimize my folder here, and I'm going to open up ArcMap, which is the application that we're going to be using today. Now, ArcMap is actually part of a suite of software called ArcGIS Desktop. It's very much like Microsoft Office. It contains several different programs that do different things. Well, ArcMap is one of the programs inside ArcGIS, and we use it for dealing with spatial data. So I'm going to cancel this getting started page, and I'm going to make sure you guys can see my full application window. So ArcMap is a relatively complex application, very much like Adobe Illustrator or any of the CAD applications that you guys have become familiar with. At first, it may look like there's a lot going on, and there is, but we're going to deal with this in a very systematic fashion. So first of all, I want to point out there is a row of menu items at the top. Each one of them has a drop-down menu that you access just by clicking on the name. This is very much like other applications you're familiar with. We also have several toolbars that give you access to commonly used functions. And we'll talk about several of those here in a moment. There's a gray space to the right on the toolbar. And if you right click it, you can see a long list of all of the other types of toolbars that are available in this application. We'll just be using just a few of them today, so you don't need to worry about that. But if you need to access other toolbars, that would be how you would go about it. There's also a panel over here on the left-hand side of the screen called the table of contents. And as we add data to our map, which is the larger view that you see here, as we add our data into that data view, we'll add items into the table of contents, and you'll see them appear there as data layers. So let's first of all, on the far right of the page, you should see a catalog tab. If you don't have a tab like this, I'm going to put a little pin in here so that my catalog doesn't disappear. There's also an icon on the toolbar called catalog that would allow you to see that panel that you're seeing on the right-hand side of my screen. Now, the ARC catalog is basically a file manager for geospatial information. And so think of it as the best way for you to copy and paste spatial data, and you can move that data between folders using this application. Now, first of all, I'm going to have to make a folder connection, and I want to make a connection to the I want to connect to the folder where I'm going to be storing all my data. The actual fastest way to do that is to save my map document into that folder. So I'm going to go to the File menu and click on Save. And then I'm going to go into my desktop and I'm going to find my Hodiamont folder. And in that folder, I'm going to change the title of my map document from untitled.mxd, and I'm just going to call this Hodiamont MXD. The .mxd extension means that this is a map document, and that's the native format for ArcMap. So I'll save that. And when I do it, you may have noticed that the home folder in my catalog tab changed to desktop/Hodiamont. So that's the folder that my map document here is stored in, and it also contains that source data that we downloaded. So I'm going to expand that folder, and you'll see there I've got this grg gisdata.gdb. I've got neighborhood_boundaries.shape, par.dbf, prcl.shape, and wards_2010.shape. So these are the shape files and the geodatabase that I downloaded. And I'm going to expand the geodatabase, and you'll see that there are several data sets inside the geodatabase. Each one of those are referred to as a feature class, and a feature class is very similar to a shapefile. Each feature class or shapefile represents a curated set of spatial information that usually models the same type of features. And so I want to add some data into my map so we can begin to have a look at what these data sets look like. So first of all, to add data into the map, there are two options. You can either use the Add Data button, which is here on your toolbar, and just click on it and browse to where the data is that you want to locate it. I'm going to go to my home folder, which is here, double click on the source data, and then I'm going to open up the geodatabase, and I want to add this active Greenways layer. So I'll highlight it and then click Add. And that basically adds a bunch of line features into my map view or my data view, and it adds an entry into my table of contents that refers to that active Greenways layer. Now, I also want to bring in some other data, and I'm going to do that using the catalog tab and a drag and drop operation. So I'm going to minimize my GIS or my geodatabase, because that's the only layer I need is that active Greenways. And then I want to bring in some of the other layers. And the first one is the parcel.shape, PRCL.shape. And you can just click on that and then drag it. And you can either drop it in the map or you can drop it in the table of contents. I'm just going to drop this in the map, and you'll notice that it has given me this geospatial or geographic coordinate system warning. Now, I don't want to go too much into detail here, but the coordinate system for my PRCL data and the coordinate system for my map document are different. That's because when I bring in the active Greenways layer, it sets the coordinate system for my entire project. And so now anything that I bring into the map that differs from that is going to show me this warning. Right now, we're going to ignore it, but later on, we'll come back and talk about why this is an important thing to know about and why I don't want you guys to check these boxes that says, don't warn me this session or don't warn me ever again. You actually want to receive these warnings so that you're aware of the issue that your data sets don't have the same coordinate system. But for the moment, let's go ahead and just click close, and that will bring in our parcel layer. So this is the property boundaries for every piece of land in the St. Louis city limits. And as you can see, it's populated a bunch of polygons, and you can see the familiar shape of the city of St. Louis. Now, I want to bring in a couple more data sets: neighborhood boundaries, street center lines, those are in my GDC collection. So let's bring in the neighborhood boundaries. Just click, and instead of dropping it in the map, I'm going to bring it over and drop it in the table of contents just to demonstrate that. You see that black line? It shows you where it's going to go in the drawing order. And for right now, I'm just going to put this right up on top and let that go. Now, the other place that we wanted to add data from is a network location. The geographic or the geospatial data collection is a networked location that you guys have likely mapped to from your computer. So if you don't have if you've got it mapped on your computer, you'll need to create a folder connection to it. And this basically tells ArcMap that I have a link somewhere on my system to another location. And so you use the folder connections window. You can right click and connect to folder, or there's an icon in the toolbar at the top here for connect to folder. And we'll quickly just browse on my computer. I've already linked to the library's GDC and the active folder. And so I'm just creating a connection in my software to that particular location on disk. I'll just create a connection to the geospatial data folder. And that adds an item into my folder connections that allows me to browse that network location. And so I'm going to expand the geospatial data, the region, and then STL Metro to see the STL City folder. Now, these are all layers that we've accumulated over the years of spatial information that is associated with St. Louis City. There's a couple of data sets I want to bring in. One of them is in the STL_city data geodatabase. So expand that. And actually, there's two things I want to bring in here. Let's bring in the St. Louis City schools. It's a point layer, and you can see that from the icon that shows you that little point symbology. And I'm just going to click and drop that into the map. And then at the bottom of that geodatabase collection, there's a street center lines _STL city. These are the street center lines for city streets. And I want to drag that in, drop it in my map as well. And then there's one other thing I wanted to bring in, and that is some building footprints. These might be very interesting to you guys. That's located in the St. Louis City parcels folder. There's a folder called buildings, and then a BLDG footprints.shape. And this is a shape file of building footprints. So bring that in and drop it on the map as well. Okay, that's all the data sets that we're going to load for now. Just keep in mind that the catalog tab is the best place for you to manage your data. If you wanted to take this building footprint shapefile, for instance, and make your own copy of it, you can actually right click it just like you would in a file manager and copy that file into a local folder like our source data folder. I'll show you another method of getting a subset of that data later on in the demonstration. But for right now, we are finished with the catalog tab. And at the beginning, I actually pushed in this little auto hide pin at the top of the menu. I'm going to pull that pin now, and that catalog tab is now docked over here on the far right side of my window. I'm going to pause here and just take a quick sip of water. Hold on. Now, while we're paused, did anyone have any issues bringing those data in? Excellent. Okay, so your map should look very similar to what mine looks like. I am going to use some of the tools on my toolbar to actually navigate about. Now, there's a black arrow up here, and it's called the Select Elements tool. And that arrow basically doesn't do a whole lot when you're in the normal view mode for ArcMap. But you can see in my toolbar, there's a blue box around it. And that just indicates that it is the active tool right now. So any of the tools that I click on, and let's say I wanted to zoom in on an area, there's a zoom tool on the far left. I just click it to activate the tool, and you can see that my mouse has changed to this magnifying glass symbology. And I'm just going to click and drag a rectangle just north of that big pale blue rectangle that represents Forest Park. So I'm zooming into the Forest Park area, and I know you guys are working in this region above it for this Hodiamont Tracks project. And so we're going to be focusing in on that area. Now, the zoom tool is fine, and as soon as I activate it, it basically changes my mouse, and now I can't do anything else until I go up and activate a different tool. I'm going to go back to my Select Elements tool, and I'll show you a few keyboard shortcuts. So the Z, the X, and the C key modify the operation of the Select Elements tool. The Z tool turns it in, or the Z key, when I depress it, turns it into the Zoom tool. The X turns it into the Zoom Out tool, and if you click and drag, it's going to zoom out your view. I also have a back button up here on the top window, this little blue arrow that takes me back to my previous spatial extent, which is kind of handy. Now, the other key, the C key, activates the pan tool. And so I'm going to activate that. And then you can see I now have a big hand here. I'm just going to shift my data set over so that my view is a little bit farther to the east. So these are the navigational tools that we might use. The globe actually zooms out to the full extent. That would take you out so that you can see all of the spatial data that you have loaded into your project. So it's going to zoom out as far as necessary to show you everything. We also have these incremental zoom in tools where if you zoom or if you click, it just zooms in a little bit and a little bit. And then a zoom out tool does the same thing. So I want to return to where I was. I'm going to use my keyboard and zoom into this area as soon as my screen stops shifting. So I'm going to Z and zoom. And now this is the spatial extent that I really want to work in on a regular basis. And so what I'd like to do is set a bookmark, because this is a place I would like to return to easily. And this is just like a bookmark in your browser. It takes you right back to that page, but in this case, it's a spatial location. So here under bookmarks on the menu bar, I've got an option to create a bookmark, and I'm just going to call this Hodiamont. And let's just add tracks, Hodiamont tracks. Click OK. And now in my bookmark menu, I've got this Hodiamont tracks location. So if, for instance, I panned, if, for instance, I panned to a different location, I can easily use that bookmark to get back to the exact same spatial extent. That's very handy when you want to define an area, a study area that you're going to be using quite a bit. Now, another tool that I wanted to define for you on the toolbar is the Identify tool. It's this blue circle with an eye in the center of it. If you activate that tool, it changes your mouse now to have this little eye icon beside it. And if you click on the map anywhere, it's going to identify the feature that you clicked on. And it places a little pop-up window that includes that you're identifying this from the topmost layer. That's the default behavior, but using this drop-down menu, you can actually change that so that you can target a specific layer, or you can target all of the visible layers. So if I changed my setting to visible layers, and then I went back to my map and I clicked on the same spot again, I'm going to get several returns now because there are lots of features that exist in that exact location. So for instance, in the building footprints layer, and if you click on the name of the layer, you'll see that it flashes the feature in the map. It lists this as the Skinker de Bolivar building. And down below in this lower part of the window, there are all of the attribute values associated with that building. And we'll talk about attributes a little bit more in just a moment. But the Identify tool basically allows you to look at different features. And in this case, we had a building footprint. Then we've got a neighborhood, which is the Skinker de Bolivar neighborhood. And we've also got a parcel there as well that represents the property boundaries. So all of those spatial features basically occupied the same space that I clicked on. And each of them contains a different set of attributes. So if I look at the neighborhood boundaries, the attributes below for the Skinker de Bolivar feature, there are significantly less attributes associated with it, and they store different information. For the parcel feature, that feature actually has very few attributes, but it does have an important attribute called the handle, which is a unique identifier for each one of the pieces of property in the city, and we'll take advantage of that later on. Okay, so that basically covered several of the common tools on our toolbar, and basically gave you a little introduction into navigating around in our map and setting bookmarks. Now, I mentioned attributes, and I want to talk about the attribute table associated with each one of our layers. So in your table of contents, you have now a layer of a line representing each one of the layers that we've added in our map, along with a default symbology that was assigned as we brought it in. So active greenways, which is the data set we got from Great Rivers Greenways, this basically shows all of the bike paths and trails that they've been, greenways that they've been working with over the years. And I'm going to right click that layer. When you right click a layer in the table of contents, it opens up a contextual menu that gives you access to a lot of different choices. And we'll deal with several of these today. The open attribute table basically opens up the underlying table that is associated with all of the features in that data set. And so I wanted to go through this real quick. Each row in this table represents a feature on my map. And for now, I'm just going to turn off several of the layers in my table of contents so that we can focus in on this active greenways layer. So I've turned off, by checking the little box or unchecking the box in the table of contents, I've turned off all the layers, and the only one I see is active greenways. Now there's one greenway here that I'm interested in. If I click on it using the identify tool, I find that this is an active greenway called the Brick Line. It's 3.75 miles long, and it's part of this future expansion for St. Louis City. Now that shows me what it is, but I also want to indicate that there's a connection between my table here and the features on my map. So I'm going to use my Select Features tool. That's another tool on my toolbar. It allows me to select manually particular features using whatever tool is defined as the default. In this case, I'll use this rectangular tool. And so I'm just going to click and drag a rectangle about that feature. And you can see when I do it, it highlights the feature, and then it also highlights a row in the table. And so that indicates that that feature is actually associated with one record in my table, and the attributes that I was seeing are the columns in that table. So the greenway name, here it's called Brick Line. And so geospatial data is like that. There's a row in the table representing each one of the individual features in my map, and I can use that to identify information about those particular features. And we'll come back to using other attributes here in a moment. So I'm going to close my table. I just clicked on the X in the far right. I'm going to go back and activate my Select Elements tool, which is kind of my default tool. And then I'm going to pull up one more attribute table. So let's pull up the parcel layer. I'm going to open the attribute table there. And there's just one other thing I wanted to point out about attribute tables. The table itself contains all of that attribute information. At the bottom of the table window, though, you can see 0 out of 127,388 selected. This indicates that there are that many parcels in the city of St. Louis. And so this data set has 127,000 odd records in its in this data set. Each one of them has a unique handle, and we'll later on use that handle to associate these features with some tabular information that we might want to use for our purposes. Now I'm going to close that. And I'm going to go back up to my toolbar. There's a clear selected features tool just to the left of the black arrow. And you'll notice when I mouse over these icons, it shows me a little tip indicating what that icon is supposed to do. That'll help you remember those things. And when I clear that selected set, you'll notice that the symbology changed on my, the highlighted symbology was removed from that particular symbol. Now, the table of contents on the left-hand side of the page is a very important way for you to interact with your features. It gives you access to those contextual menus, but it also controls the way the layers are drawn and the order in which they're drawn in your map document. So I'm just going to turn everything back on again. And you'll notice that in the map, things are drawn from the top down. or I guess you could say from the bottom up also. So the parcels are drawn, then the active greenways, the neighborhood boundaries, building footprints, street center lines, and city schools. Now, it's a very busy view right now, and it's difficult to see things. So first of all, let's change some of that symbology. So my active greenways, I'm just going to click on that line symbol underneath the line, and it opens up my symbol selector. This allows me to either manually change the color and width or to apply a default symbology immediately. And I'm just going to use this highway symbology right now. It applies a red color with a 3.4 point width to that feature, and I'll click OK. And as the screen redraws, you can see the line popped in there for just a moment, but now it's been obscured by the layers on top, the neighborhood boundaries and the building footprints. These are both polygon layers with filled symbology, so it's difficult, it's impossible to see through them. And so it'd be better if my active greenways, which is really the point of our project, would be at the top and visible. And in the list by drawing order view, and you'll notice I've moused over an icon along the top of the table of contents. There are several different viewing modes for the table of contents, and list by drawing order is the one that's most commonly used, and it's the one that allows me to click and drag these features into new locations. So I'm going to click the active greenways feature, pull it all the way up to the top of my map, and now it is going to appear on top of all of those features. So that's good. I also want to make sure that my neighborhood boundaries, I'm going to move those down to the bottom. Those are solid polygons representing the neighborhoods, and they take up a lot of space, and they would obscure all of the buildings and parcels that might have been underneath them. And I'm going to zoom in real quick to a closer look at a smaller area so we can begin to see some of the details that we have in this map document. We can see the blue polygon at the bottom represents that neighborhood boundary. On top of that, we've got green parcels, and then we've got these tan buildings, and those are building footprints. Then of course, above that, we have blue street center lines. We've got our red feature representing the greenway feature. So ordering is important, but also the way that we symbolize things is important as well. So neighborhood boundaries, for instance, being at the bottom of this stack makes it extremely difficult to understand where boundaries occur. And so I'm going to actually bring that layer back up to the top, but I'm going to change the symbology. So I'll click on the feature to open up the symbol selector, and I'm going to go in and change the fill color to none. And I'm going to edit the outline symbol. So under edit symbol, I can change the outline. And in this case, I'm just going to establish this state boundary outline as my default symbology for these features. So I've selected boundary state, click OK, and then click OK again, and then finally OK to apply that change. And now we'll see that my neighborhood boundaries appear and they're visible, but they're also not obscuring the layers underneath. And so that obviously setting those things is rather important. And the symbol selector is the most simple method for making those changes. There are other ways to symbolize features, and I'll get to some of those a little bit later on in our session. So now I'm just going to zoom to the global extent here. And I do this to highlight the fact that we've got a lot of data in our project that occurs in areas that we're not really interested in. Okay, and so for you guys, the Hodiamont area is actually the place that's most important to us. We would prefer to deal with a smaller subset of the data that just corresponds to that particular area. And so I'm going to show you how to make your own copies of those data so that you can basically deal with a simplified set of information. Now, the first thing, these active greenways have names associated with them, right? And so I can use that brick line name to call out only the features that have that particular value. And that's called an attribute query. So on the menu bar, there's something called selection. And under selection, I've got select by attributes. And this basically allows me to use the attributes of those features to define a set of criteria so that I can identify specific features. So under the drop-down menu, I want to select by attributes for the layer called Active Greenways. I select that, and then it gives me a list of all the attributes in the table. I can double click on Greenway name, and when I do, it appears in this lower panel. This is basically an SQL query that is going to filter my data set based on information that I've assigned here. So Greenway name, then click once on the equal sign. It appears in the list as well. And now Greenway name is highlighted up here in this view. It's kind of difficult to see on this screen, but when it's highlighted, I can get unique values, and I get a list of all of the different names that appear in my data set. So I'm just going to double click on Brickline, and it now appears in my SQL query, and I can click OK to run that query. And now it has found all of the line features in my data set that correspond to Brickline. And in fact, you can see that there's quite a few of them. I'm going to use a little zoom. Actually, instead of doing that, I'm going to right click on my Active Greenways layer and show you another little trick. Under selection, there is a zoom to selected features option. So for this particular layer, I have some selected features. I'm going to zoom to those features, and now it changes the extent of my display so that I only see, I'll see all of those features, and I'm going to turn off some of the other layers here so you guys can see this. So now we've got the neighborhood boundaries, the selected Brickline features, and the schools are shown. Now, that's helpful. However, it turns out there's a lot more Brickline features than the single line that I'm interested in, which is this one up here in Delmar. If I open up my attribute table again for Active Greenways, you'll see that now, instead of 0 out of 52 selected, which is the way it was at the beginning, now I have 29 of 52, meaning there are 29 line features in my data set that have the Brickline as their name. And so that's not very helpful. What I'd really like to get is the one that is located up here. And I think it's this first one in the list here. So I'm actually just clicking on that. There's a gray box on the far left of my table. I've just clicked on it, and it is now the only one that's selected. You can see I've only got one selected, and I'm going to use another zoom to selected option, which is in the toolbar, and zoom so that I can see that feature. And I'm just going to move my table down so that I'm out of the way here. So now I've got a single feature selected, and this is really the only Greenway feature that I might need for this project. Let's assume that's the case anyway. So I'm going to close my table, and I'm going to show you how to make a copy of this particular feature and store it in a project data folder. So right-clicking on Active Greenways, if you go down to the Data and Export Data menu, it allows us to export selected features, all features, or only the features in my view extent. Right now, I just want the selected feature. So I'm going to leave that as is, and I'm going to use the same coordinate system as the source data. We'll get back to the coordinate system here in a moment. Then I want to make sure I'm storing this into a project data folder located in my Hodiamont folder. So I'm going to click the browse button here, and I'm going to use this home folder icon on the top bar, and it takes me to the home folder. Now I'm going to save this as a shapefile. So under Save As Type, I want to change that to a shapefile. And then I want to change the name. The default name, anytime you do one of these operations, is going to be Export Output, which is not at all helpful. So this is a very key step here. You want to make sure you're naming this. And I'm going to call it Hodiamont_line. You don't want to use any special characters or spaces when you're naming these features. So I will save that now. And instead of putting it into my regular folder, I'm going to create a new folder using this new folder option on the toolbar. And I'm just going to call this project data. Then I'll double click to get into the folder. And then I can now use the name and shapefile type to save that file. And this saves a shapefile into my project data folder. it's now, I have to click OK to finish the operation. And then it asks me if I want to bring that layer into my map, and I do. So I'm just going to click yes. And it adds a new feature into my table of contents called Hodiamant line. And it symbolizes it with a standard green, default symbology, which I will go ahead and click on and change that to the highway to make it match the active greenways. And then I'm just going to turn off active greenways so that now if I zoom to my full extent, the only greenway feature in my map is now the one that I've saved into my project folder. So later on, if they change the path of the greenway and we want to move this feature, we now have our own feature that we can edit. Let's say you wanted to propose a new path. You could move this or change its orientation, or add some length or whatever to that particular feature now that you have your own feature. So if we don't need the active greenways anymore, I can turn it off, or I can remove it from my map document. So I'm going to right click on active greenways, and I'm just going to use this remove option. Now, keep in mind, this takes it out of my map document, but it doesn't delete it from my data folder. So I'm just getting it out of my project. And now it's been quite a long time since we actually saved our map document. So I'm going to go up to the save button and perform that operation. When you're working in ArcMap, it's a good idea to, on a regular basis, go ahead and save your features, and that way you won't lose any work if the system crashes. I'm going to pause here for a quick sip of water. If anybody's got a question, let me know. Okay, thank you. Now our session is going to last about 2 hours, so we've got another hour to go. Is that okay, Petra, or do you think we need a break? Okay, good. Everybody's good to go. I'm going to keep. Yeah.
Maybe we have a 5-minute break when it's good for you.
Well, actually, this might be a good time. We just did a save, and okay. I could use another sip of water. So yeah, let's take a quick 5-minute break. I will. I'm just going to actually turn off my video, and I'll come back in 5 minutes.
Sounds good. Thank you.
You're welcome. Okay, I'm back. Hopefully everyone else is back. I see several cats in the session today. That makes me wish I had mine with me. I'm on campus today, so I'm not working from home. Otherwise, I would have my 2 cats with me too.
Next time.
Yeah. Okay. So let's see. The next thing I want to show you is several other methodologies that we have for selection. So select by attributes is a great way to select features if you know the type of attribute that you're looking for. But let's say that we wanted to manually select some items. So I'm going to use my bookmark to get back to my Hodiamant tracks area. And I'm going to actually shift this a little bit so that I can see all of that red feature. Now, since I'm changing the orientation of my space here, and actually I'm going to zoom out just a little bit because I want to capture this other neighborhood down here at the base. I've actually changed the extent that I want to use for that particular bookmark. So I'm going to go up to my bookmarks menu and manage my bookmarks. And then under Hodiamant tracks, I'm just going to right click and update the extent. So this now has updated my bookmark to the new location. Now, I've got a couple other ways to select features, and I'm interested in the neighborhoods that this line passes through, but not really any of the other ones. And so I'd like to make a data set that only includes those layers. And so I'm going to use under the selection tool, under the select feature tool in the toolbar, I'm going to select by rectangle. And that allows me to drag a rectangle around features that I want to select. But I only want to get features from the neighborhood layer, right? And sometimes if, for instance, I had building footprints under display, I would have a lot of features in my way that I would need to worry about. But I can actually go to neighborhood boundaries, right click on that layer, and under selection, I can make this the only selectable layer. That makes it much easier for me to deal with selecting those features. So now that that's activated, I can click and drag a rectangle that captures 2 of those neighborhoods. Then I can use my shift key to click and drag another rectangle to add features to that data set. So I'm holding my shift key down, and I'm just going to drag several more. And let's say I went a little bit too far and I got an extra one here at the end that I don't want. I can shift click it to remove it from the set. So now I've got a selected set, and actually looks like I missed one here. I shift clicked this one. And so now it looks like I've got all of the neighborhoods that line is passing through. And so these are another data set I'd like to capture and create my own copy of. And so I'm going to go back to neighborhood boundaries. I'm going to go to the data menu, export data. And I'm going to export the selected features using the coordinate system of the source data. And I'm going to export into my project data folder. Instead of Hodiamont line though, I'm going to highlight that so that it moves the name down here, but I'm going to take line out and put in neighborhoods. And then click OK. Add that to my map. And now I've got my Hodiamont neighborhoods, but it's applied this messy symbology again. So I could go in and change those values, and it's relatively simple to do that. But I've got another layer in my map that's already symbolized the way I want it. And maybe I took several minutes to define a very specialized symbology that I want to use, and I don't want to have to do that again. I can actually apply a symbology that's associated with a different layer using the Symbology tab. So I'm going to right click on the Hodiamont neighborhoods layer, and I'm going to go down to properties. All of our layers in the table of contents have their own property window that includes several different tabs, including one called Symbology. Now, the Symbology tab that we've been dealing with, the symbol selector, which is activated by clicking on the symbol in the table of contents, is a very simple. This is the way it's symboled, and I want to change it to different settings. The Symbology tab in my properties window allows me to do different things. I can use a single symbol like we have been doing, or I could use categories or even quantities to symbolize these features. And we'll come back to this a little bit later, and I'll show you how to use quantities and categories. For now, I want to focus in and draw my symbols the same way, but I want to import that symbology from a different layer. So I've got this import button here. It allows me to take any layer that I specify, and these are all polygon layers because I'm symbolizing a polygon layer. So I'm going to select my neighborhood boundaries and just click OK. It's going to apply that symbology. I'll click OK. And now my new layer has the same symbology as my old layer. I'm just going to clear my selected features. And then I'm going to right click and remove my neighborhood boundaries layer. And now I've simply got my Hodiamont neighborhoods. Now, I've got building footprints. I'm going to turn my parcels back on, and I'm going to turn my street center lines back on. And I've got quite a busy map here now. I've got a lot of features that are difficult to see. If I was making a map, I wouldn't want all the extra parcels. I wouldn't want all the extra buildings. So I'd like to subset them, and I don't want to have to go around and draw a bunch of little polygons to select those things. So what I'm going to do is I'm going to use my Hodiamont neighborhoods polygons to select using a topology. And that's basically a selection by location operation. So under the selection menu, I've got a select by location operation. I'm going to select features, and I'm going to target 2 layers here. Well, actually, I'm going to do this in 2 steps. You could target more than 1 layer at one time, But for now, let's start on the parcel layer. So I'm going to start with parcels, and I'm going to use as a source layer, not the Hodiamont line, but the Hodiamont neighborhoods. And I am going to use a spatial selection method. On this drop-down menu, you'll see that there are quite a number of different selection methods that I might use. For parcels, I want to find the ones that intersect the source layer features. So basically, if a parcel is touched by one of my neighborhoods or falls within it, I want to select it. And that's what this operation will do. So I'm going to apply that. And now we should see a selected set of parcels appear on my map. And these are all the parcels that fall within or touch the boundaries of those neighborhoods. And so with that selected set, I'm just going to click OK. It's going to actually perform the selection now. And then I'm going to go to the parcel menu. I'm going to right click and go to Data, Export Data. I'm going to export the same coordinate system as the source layer. And if you'll recall earlier, this was the one that had a problem with the coordinate system. So I want to retain that problem in this new data set so we can deal with it later. I am going to browse, and in my project data folder, I'm going to call this Hodiamont parcels. And I'll save that shapefile. Add it to my map. And now I'm going to turn off the original parcel layer. And you can see now I've got all these purple parcels in my neighborhoods. Now, the other thing I want to do is a select by location to grab some buildings, but I don't want to get all the buildings in the area. Maybe we're interested in this greenway. And so I'm interested in buildings that are close to the greenway, but not necessarily the ones that are farther away, even if they are in the same neighborhood. And so what I'm going to do is go to selection by location. I'm going to, instead of parcels, I'm going to select from building footprints. And instead of neighborhoods, I'm going to use my Hodiamont line as the target feature, as the selecting feature, basically. And I'm going to apply a search distance. So anything that is, first of all, in the spatial selection method, I'm going to say are within a distance of the source layer feature. So that's the methodology I want to use. And then I need to specify what that distance is. And let's just use 1,000 feet and see what that looks like. So I'll click apply. And you'll notice on most of these windows, there's an apply button and an OK button. The apply button does what you ask it to, but it leaves the window open so that you can make some changes and do it again. The OK button says, do it the way I asked you, and close the window. So now you can see I've got buildings selected that are within a distance of my line feature. Some of them are fully within the neighborhoods. Some of them, in fact, are outside of the neighborhoods. That's okay. I'm okay with that for the moment. So now I'll click OK, and then I'm going to export this data set as my Hodiamont buildings. So from building footprints, I'll go data, export data. This should be becoming old hat by now. And I'll call that Hodiamont BLDGS. Add it to my map, and I can get rid of all the other buildings now too. So the building footprints I'm going to remove. Parcel layer I will remove. Now, street center lines is a different story, and I'm going to quickly deal with that. So let's say I wanted to select by location all of the street center lines that fall within the neighborhoods. So I'm going to say are within the source layer feature. And I'm not going to apply a search distance. So I'm going to apply that now. And you'll see that I get some streets, but not necessarily all of them, right? Some of the streets extend beyond, and we're not getting all of them. It's because these street features don't necessarily end at the neighborhood boundary. And some of those street features extend beyond the neighborhood boundary. But this selection is only finding those that are within the source layer feature. So let's say I found all of the ones that intersect that source layer feature. Let's apply that. And you'll see now I've got streets that extend beyond the neighborhood features. And maybe that's not what I want either. Maybe I'd like to get the street features that fall within the neighborhoods, and that's it. And I'd like them to end at the neighborhood boundary. And so there's another operation we can do. And in fact, this isn't in the notes that I've shared with you, but it's called a clip. And we're going to use the Hodiamont neighborhoods to clip the streets like a cookie cutter. So I'm going to close this selection and clear my selected features. And then under the geoprocessing drop-down menu, there are several common geoprocessing tools. We're going to use the clip tool here. And this is basically like a cookie cutter operation. It's basically going to take those street features and clip them with the Hodiamont boundaries. So the input features are the features to be clipped. And this is something I want to point out here on this tool. All of the tools have entries that must be entered, that they're denoted by these green dots. So you must put a value in there before the tool will run. They also have this little tool help menu, and that is under show help or hide help. So make sure that this is visible, because then when you click in the field, it will give you a little tip as to what that is supposed to be. So the input features are the features to be clipped. And for those, under this drop-down menu, it shows me all of the layers in my map document. And so these are the features that are going to be clipped are these street center lines. So I'll select that. The clip features, which are the features used to clip the input features, that's going to be my Hodiamont neighborhoods. And then the output feature class is going into my home folder, project data, and I'm going to call these Hodiamont streets. And click OK. Now you see all of the green dots are gone. So my OK button is active now, and I can run that tool. It just takes a moment. It'll pop up this little window that shows you that the tool ran. It usually gives you some information about what the tool is doing and how long it takes. Sometimes it'll show you how many features that it operated on. But if you get this succeeded message, as long as you get that, you can just close this without worrying about what it really has to say here. If there was an error, it would show you an error in the window there, and you would be able to use the messaging to try and figure out what it meant. So right now I'm going to turn off street center lines, remove it, and I'm going to actually turn off some of this other stuff so that we can actually see what these streets look like. So now the streets end at the neighborhood boundary. So I've created a set of streets that only apply to my project area. Okay, buildings, turn back on, parcels, turn back on. And for now, I'm not gonna deal with the fact that the schools, there's actually one school near my area of interest, but that's it. Actually, let's see, I'm gonna push this all the way to the top. It's hard to tell. Yeah, there's actually a school inside the area. And so I'm gonna zoom into that using my Z key and my school. And I'm interested in finding out exactly what that school is. So I'm gonna use the identify button. And I'm going to mouse over that one point, and it's using identify features from visible layers. If I focus on the topmost layer and do that again, as long as I'm careful about pointing there, I find that this Soldan International Studies High School is the one school that falls within my study area. So I'm going to do something different with this layer. Instead of creating my own subset of this, maybe schools are important, maybe they're not. I'm going to use a definition query. So I need to use I need to get to the properties window again. I right click, and it's the properties window here at the bottom. Another way to open that window is just double click on the layer in the table of contents, and it defaults to opening this window. And there's a definition query tab here. The definition query basically is very much like an attribute query, but it filters the data set before it's even visible in the map. So we had several schools that were visible, but I'm going to build a query using the school name. So I've found the attribute name, I've double clicked on it, equals, get unique values. And now I'm going to scroll down until I find that Soldan International Studies High School. I'll double click it, I'll click OK, and then I'll press OK. And now if I zoom to the extent of my layer, I'm right here, and this is the only school that's visible. So I've basically told the system, yeah, I've got a data set of schools out there, but I'm only interested in one of them. So that's the only one I want you to bring into my map. And this is another way of basically simplifying a data set without having to create your own copy of it. Now, the school symbology is not very helpful here. That's that small dot. If you click on the school to open the symbol selector, I can actually use a search bar here at the top to search for school. And then any of the symbology in the software that is identified as a school symbol will show up here. And so I'm going to use this nice red schoolhouse and click OK. And now that'll use that as the symbology for that particular school. I'm going to go back to my Hodiamont Tracks bookmark. And at this point, let's see, let me check my notes here. At this point, I want, oops, sorry about that. At this point, I want to show you how to label features. So the attributes that we have here, or the features that we have here, many of them have attributes associated with their name. The one thing that we might want to label in this map at this particular scale might be the neighborhoods. And so I'm going to go to the Hodiamont neighborhoods layer. I'm going to right click, and one of the items in the contextual menu is label features. And this basically turns labels on and off. So I'm going to use that, and I'm going to turn off some of my other features so we can see this. It's applied these very simple standard labels to each one of the neighborhood polygons, centering them and basically using a very small font. Not something that is extremely compelling. And so maybe I'd like to alter that in a little bit. So I'm going to open the properties, and there's a label tab in our properties window that gives me many more options. The on and off option here is this checkbox in the upper left corner. And the method I used to turn them on originally basically checks this box or unchecks it. If it's checked, I can use the settings down below to alter the way the symbology is shown. And so I'm just going to change this to use a much larger font, let's say 14. I'll make it bold. And then I'm going to change in the symbol. I'm going to use the symbol button to go in a little further. And there are several default symbologies I could use. In this case, I just would like to get a little halo around that symbol, so around those letters, so they show up a little bit better. And I wanted to point out there are lots of different options here for setting this symbology. Under mask, I'm going to set the halo. I'm just going to use a 1-point halo and click OK, OK, and then OK here. And now it changes the size, it changes that font. And so I can adjust my labeling symbology that way. And if for some reason I decide later on I don't want it, I can just turn it off using that option that I originally used to turn it on. So for now, I'm just going to leave that on. And so now we're getting to the point where we've got kind of a map going here. I'm going to go ahead and turn the parcels back on. At this sort of scale, parcels might be something that I would be interested in showing. Buildings, if I use the buildings, they're a little bit too small to actually be of use at this particular scale. And while we're talking about scale, I wanted to bring in the idea of creating a layout. And a layout is basically the mode that we've been working in so far is called data view. It allows us to interact with our data, looking at it at various scales, and performing selections and other types of geoprocessing. But when it comes time to make a presentation or make a figure, I need to use a layout in order to make that happen. And so at the lower left-hand corner of my view frame, I've got data view and layout view. Those are the two different view modes, and data view is kind of highlighted here. And so that's the one that's active. Just click on layout view to activate that particular methodology. And you can see you get a page design view of the software. And in this case, the orientation of my study area is such that I'd rather have a landscape orientation. So I'm going to go up to the File menu and Page and Print Setup. And this allows us to set up the page design for how I would like to make an output product. I'm going to, instead of using a letter size page, I'm going to scroll up to the top and use 11 by 17. You can set up custom page sizes here. That is certainly something that you could define. And I'm going to define a landscape mode as the way I would like that page to be designed. Click OK. It now changes that. And then the data frame, which is what this little element is referred to, also refers to this layers option in my table of contents. This is referred to as a data frame. And I'm just going to change the name of it by clicking on layers, and I'm going to call this main map. Then I'm just going to open it up again, and you can see all those layers are there. Now, my select elements tool is active, and in layout mode, that's when this tool becomes really effective. It allows me to click on items. If I click off of my data frame, it unhighlights it. If I click on it, I can use these little grab bars to extend the size of it and change its shape. Of course, it stays as a rectangle. But let's say I'm very particular about how I want this to be arranged on my page. I can right-click on my element and open up its properties. And the properties here have several different tabs associated with them. One of them is size and position. And so I can say the position, which is defined as with the anchor point here at the lower left-hand corner. Let's say I want to make that at 1 inch by 1 inch. So I want that to be at the 1, 1 location on my page. And I want my width to be 15 inches. So I have an inch on each side, and 9 inches. I'll have an inch on each side there. So I'll set that up, click OK. And I'm getting a transformation warning. We'll deal with that here in just a second. So I'm going to click yes. And now I have my data frame is the size I want it, but my data is now too small. So I need to zoom in. And you may not have noticed, but we have a layout toolbar at the top. If you go into layout mode, this toolbar should be activated. If it's not, you can find it by right-clicking and making sure the layout bar is checked. This has several zoom tools on it and navigational tools, but they apply to the page. So if I use the zoom tool here and zoomed into the corner of the page, it's going to make that part bigger. Excuse me just a second. Oh, sorry. I have a visitor to the office. So it zooms in on the page. I'm going to zoom back to full extent here. And then the zoom tools that we used originally refer to the data frame that's active in my map. So I can click my zoom tool and I can click and drag to zoom into that particular location. My bookmarks still work. So if I use my Hodiamont Tracks bookmark, it's going to zoom in there. And if I wanted to make some minor adjustments, I could use the pan tool and move that around on my page. So it allows me to perform those design operations. Now, the other thing that I might want to include in a map like this would be certain elements, standard map elements like titles, north arrows, scale bars, etc. And the insert menu, that drop down really only applies when you're dealing in layout mode, because this allows you to add individual elements. And I'm just going to add a few quick ones. So I'll click a title. I'm going to call this Hodiamont Tracks project. That adds an element here at the top. I'm just going to add a few more elements really quickly. A north arrow. I'll just select one of my favorites. It adds it to the map. And then I'm also going to insert a scale bar. Just pick one, click OK. And then I'll also insert a legend. Now the legend is where it gets a little bit complicated. The legend, every item in your data frame is going to show up as options to put in your legend. The ones that are visible in the data frame are automatically included in the legend. And you can leave them there, or if, for instance, you wanted to remove one, let's say we didn't want schools to be there, if you highlight it by clicking on it, you can use the arrow here to remove that layer, or you can click on it and use the arrow to put it back. So those are all items that are in my legend now. I'm going to leave them as is. Maybe the order could be changed. Maybe I want points at the top. So my schools, if it's at the bottom, I can highlight it, move it all the way to the top. Let's say I want the Hodiamont line to be next in line, and then I want streets, parcels, and neighborhoods. That seems to be a good order for me. I'll click next, and I'm just going to click next through the rest of these options, except for the frame. I want to put a border around this of 1 point and define a background with a gray color. Those are just quick options. They may or may not be very aesthetically pleasing, but for now, I'm just going to go ahead and click next and finish, and I get a legend that I can click and drag to a new location on my map. Now, the legend is dynamic. It's associated with the items in my table of contents. So you see Hodiamont _ is actually the name of my layer. And I know that's not necessarily the name we might want to refer to it as in this project. So I'm going to remove _ and put in space track. So now Hodiamont track in my table of contents corresponds to Hodiamont track in my legend. So you can see there's a dynamic connection there. I can make changes in my table of contents. It will show up in my legend. So and the same goes for my symbology. If I made changes, maybe the parcels, I'm not too keen on that color. Maybe I want to make it a light green, so I can change that, and it's going to automatically update my table of my legend there. Now the other elements in the map, if my select elements tool is active, I can click to activate the element. I can either right click and open the properties, or I can click and drag it to a new location. I can size it by using those little grab handles. I'm going to click and drag the scale bar down. And one thing I want to point out, let's say I change the scale of my map. Let's say, for instance, I wanted to zoom in on a particular area. If I do that, it changes what's viewed here. It also changes that scale bar. So the scale bar is a unitless representation of size on the map, and it is dynamically associated with the data frame that was active when the scale bar was generated. I'm going to use my back bar to go back to my previous extent. And the other thing I wanted to do here, the Hodiamont Tracks project, that title isn't very well placed, nor is it big enough. So I'm going to right click and open up the properties, and I can change the symbol here to just make that a lot bigger, and maybe use bold, and click OK. So those changes can be easily made, and then I'll end up with that project. Now I've got about 20 minutes left, and there was a couple of things that I wanted to talk about quickly. So I'm going to save my map document again, and I'm going to go back to data view, because when we started, we talked about a mismatch between the coordinate systems, right? And so I'm just going to zoom in to an area right here where the line is curving, and I'm going to turn on my buildings, and I've got my neighborhoods. I'm going to turn them off. I'm going to turn off the track and the streets. And there's an issue here that you can see the buildings and the parcels aren't lining up properly. Especially up in here, you can see there are areas where the buildings are not falling within the parcel boundaries. Now, there's a couple of reasons that could be driving this. One of them is a mismatch between the coordinate systems for these particular layers. And I know that's the case because the parcel layer, when I brought it in, it threw up an error and said there was an issue. And so I'm going to go back to my Well, actually, the first thing, before I do that, I want to show you another visible option that helps you evaluate whether your data is lining up well, and that's called a base map. So under the Add Data button, there's a little drop down there that allows you to add data from ArcGIS Online. The ArcGIS Online is a dense set of spatial information that you can add to your map. And one of the things that they have there is imagery. So I'm going to search for imagery, and it's going to return this world imagery, which is a very clear layer of highly developed aerial imagery. And I just want to add that to my map as a base map. So I'll click the Add button. Just so you know, there's lots of data in ArcGIS Online, demographic data, all sorts of data. If you're looking for something, that is a good place to start. Now, I'm getting another geographic systems warning here as well, and I'm going to show you how to deal with those here in just a second. So just click OK there, and it's added the base map at the top of my stack. So I'm going to drag that down to the bottom so that now all my other features appear on top of it. And you can see there's kind of a mismatch. The buildings may not be doing so poorly, but the parcels are way off, right? They're falling outside the boundaries. Some of them are, the edges are in the roads, and they're not fully filling those spatial areas where we would think they might want to occur to cover the parcel areas that we can clearly see here. So that's due to this mismatch in coordinate systems. So I'm going to go back to the main map, to the data frame, and I'm going to double click to open the data frame properties. One of our property settings is coordinate system. And this basically shows you under the layers folder, it shows you the different coordinate systems assigned to each one of the layers in my map. And I've got 3 different ones. This WGS 1984 is associated with world imagery. The NAD 83 State Plane, Missouri is associated with all of these layers. And then NAD 27 is associated with parcels. It's beyond the scope of this session to deal with exactly what all these differences mean. Basically, they're just different ways of defining position on the Earth, and they don't necessarily line up well unless you perform what's called a transformation. And that's what this button down here at the bottom is all about. So take note before we do this of what the differences look like, right? Between the parcels and the boundaries of the property, which you can kind of make out from the grassy areas here and the images. I'm going to click on transformations, and you'll see that we need to convert from this North American 1927 data into 1983. That's because 1983 is the default coordinate system for our data frame, but it doesn't have a choice here as far as what transformation to use. If you click on the drop-down menu, you will see there is a long list of possibilities. And all of these are designed to address a transformation for particular areas of the Earth. ArcMap has graciously moves the most appropriate option for your particular study area to the top of the list. And so we can just click on this one and we'll use it to make that conversion. And then I also want to click down here on GCS WGS 1984, and I'm going to make this selection here to do that transformation. So I'm doing transformations between 1927 and 1983, and this 1984 and 1983. I'm bringing them all into agreement. Once you've made those settings, you can click OK, and then you can click OK to apply them. And now you may not have noticed on the screen, but the parcel layer has shifted, and it more exactly agrees with the grassy areas. And I'm just going to change my parcel boundaries real quick to use no fill and a little red line so that we can see them easier. And now you can see the parcel boundaries are lining up a lot better. And so that's a key step in dealing with GIS data, is to make sure that transformation is happening so that your data lines up. You don't want to have to deal with this in another application because GIS is designed to make these alignments and do this properly. You would want to do this before you exported the data. Now, one thing I will point out, if you look carefully, you may notice that these lines don't exactly line up with the edges of the grass in some cases, and in some cases the buildings are not necessarily fully within the boundaries of those parcels. There are several reasons for that. Some of them could be the fact that these layers are digitized based on heads-up digitization. So someone would have pulled up an imagery layer, traced a building footprint to build that polygon layer. And so as you can imagine, it takes a lot of work to do that. And the area changes over time. And so you can see buildings that are not in our building layer, but actually are in the imagery. And so there's a timing issue as well. The other thing is there could just be a difference in resolution. Maybe instead of digitizing at a zoomed in level like this, the person who was doing this work was zoomed out to a farther level. And so they weren't able to make as accurate a line feature or a polygon feature as they may have wanted to. So there's lots of reasons why that disagreement may occur, and it's not necessarily associated with that coordinate system, but the coordinate system is a fundamental thing that you want to ensure is correct. Now I'm going to save this map document, and I'm going to go back to my Hodiamont Tracks bookmark, and then I'm going to actually go back to my layout. So I'm going to turn off the world imagery because at this level, maybe that's not what I want. And I'm going to turn my neighborhoods back on and my track back on, and change the color so it stands out a little bit from the background. Okay, let's say you've created this feature or this figure, and now you want to export it and use it in another application like Adobe Illustrator, which is a fine thing to do. There is, under the File menu, an option to export this map. When you do that export operation, there are several different formats that you can save it as, including Adobe Illustrator. This will save it out, and full disclosure, I am not an Adobe Illustrator user. You guys will have better luck with that. But in an Illustrator format, this is going to come out as different layers and different levels of detail, and it may or may not be easy to work with in that fashion. Another way to deal with this is to create the image the way you want it here, and then just import the image into your Illustrator and don't change the size. If you start dealing with this data in Illustrator, you're going to be changing the size and the scale. And if any scale bar that you've created here is only going to be good if you scale this, if you adhere to the, I'm at a loss for the term now, the orientation, right? Somebody help me here. It'll come to me. You don't want to shrink it too far in one direction without shrinking it the same way in the other direction, right? And I know there's a term for this, I just can't remember it, sorry. So when you put this into Illustrator, you don't want to do that without being mindful of the scale. But let's say I wanted to export a PNG or some other image format. I'm just going to create this. There are ways to increase the resolution, by the way, and you want to pay attention to that when you're doing the export, especially if you're going to be scaling that image up or down. Higher resolution obviously is better, but I'm just going to save that. And then I'm going to save my map document, minimize it, and I've got about 10 minutes left, so I'm going to stop talking here and allow you guys to ask specific questions. And don't wait on me to call on you. Just speak right up if you have a question.
Hey, Bill, I have one. I
Yeah,
think I missed the step where you brought in the aerial image. So I was wondering if you can get back to Arc Online again and just show where that is.
Absolutely. Yeah, I just want to pull up that Hodiamont PNG real quick. And so it's a direct copy of what you saw in the map. And so, yes, let me go back to ArcMap. So there's a little black drop-down arrow right beside the Add Data button. And on it, you get Add Data, Add Base Map, which actually is an older, it's an older methodology for bringing in a base map. I recommend using the Add Data from ArcGIS Online instead. You get the same options. In fact, you get many more options. If we were to add base map, you'll see that there's just a limited set of options here, and these are not optimized for display, although they are serviceable. So if you decide you like one of these, there's nothing wrong with using it. But I'm going to cancel that and go back to the drop down and add data from ArcGIS Online and just search on imagery in the search box, and then that's going to return hundreds of different options, and some of these come from different places, right? The Esri symbol here indicates this is from the company that makes the software. They make a lot of data available through this platform. But if we scroll down, there should be images from other places, and they may or may not be as useful. I clicked on the details. It shows you who the owner is, when it was modified, basically gives you, in some cases, a description, but not all. But if you're searching for other types of data, do pay attention to what the details tell you, and because you may or may not get an authoritative source there.
Okay. I had another question too. Thank you
Sure.
for that. So like, let's say you wanted to zoom in to like a block scale and apply like a true like 1:40, 1:20 scale. How did you do that real quick?
Yeah, that's an excellent question. So there's a scale bar here on the top tab, and this is a true scale. So it's unitless. So if you want 1 inch on your map to equal 50 feet, you need to do the math to determine that's a 1:600 scale. Okay.
Okay.
And so then you could just type in 600 here, and that's going to zoom on your map to that scale. It's also changing the scale bar in this case, which is defined as having a miles unit, and that's not very helpful. So I'm just going to double click on the scale bar to open up the properties, and then you can change under scale and units. You could change the division units to whatever of these other values you wanted.
Okay. What was that? I'm sorry. What was that conversion that you just did though? Just get 600. How did you do that?
Well, the scale represented by this drop down menu up here is a unitless scale. And so you were talking about, well, you didn't mention a scale, I did. 1 inch equals 50 feet. And so you would need to make the units match between those two to basically take them out of the equation. So in 1 inch, how many inches are in 50 feet? It's 12 inches to a foot. So you do the math, and
Okay.
you end up with 1:600.
Gotcha.
Sorry,
Okay, so
I went through that quickly, but that's basically what you have to do. Now, that means that this image at this particular scale and orientation is 1 inch to equals 50 feet on the ground. If you take this into Adobe Illustrator and increase its size, the scale bar is still going to be accurate, but 1 inch on your poster may not equal 50 feet on the ground anymore. Does that make sense?
Yeah.
Okay.
Yeah. And then one more question. I'm sorry. Let's say you wanted to like export this data into like a CAD file.
Yes. Actually, that is covered in the documentation in the Word
Okay.
document that I gave you
I'll
guys.
look then.
Well, I can show you real quick. There's an option under data to export data, and then there's also an export to CAD. And
Okay.
what I recommend is you limit your data set first, because this export to CAD tool, I've had problems with it when I deal with very large numbers of features. So now that we have limited the parcels and the buildings and such, this would be an appropriate operation to go for. And you can export not only the track feature that I started from, but I could add other features as well using the plus symbol. Actually, you add, say, streets, and then you just add buildings, and it's going to add them to the list, and they'll all go into that same CAD file.
And then is it understood that when it comes in, that scale is going to be worked? So you'll have to rescale it just like we did. So like to get 600, right?
Yeah. Unfortunately, I'm not a CAD user either. Sorry.
Okay. No worries. Yeah.
And so I do know that CAD is actually capable of opening shapefiles. I think you have to have an extension to do it, but it is capable of consuming shapefiles in their native format. So
Okay.
you may not need to go through all of this process. I recommend checking the CAD documentation first, see if you can bring in the shapefile. And then I think it depends on how your CAD project is set up, whether you've defined a real world coordinate system or a local coordinate system. And,
Right.
and then that's going to determine how well it lines up.
Okay, thank you.
You're welcome. Anybody else?
I have a question. Are we able to remove the data frame on the layout? Like if I don't want a frame on the paper.
Yeah, so you would want the data frame to fill the space. Is that what you mean?
Yeah,
Or
yeah.
do you want more data frames?
Like to remove this data frame.
Yeah, I mean, if you wanted to remove the data frame from the page, I guess I don't understand what advantage that would, because you'd have a blank page then.
Yeah, maybe sometimes I just want the image of, I don't want the frame outside on the page on the white paper. I don't want a frame there.
Yes,
Yeah.
I understand. Yeah, sorry about that. So under the properties for the data frame, there is an option for the frame, and we have a border assigned to it, but you can make that none.
Okay.
So then you won't have that black line. That's what you
Okay,
meant,
okay.
right?
Yeah.
Yeah.
See, thank you.
Sure. Yeah. The data frame itself is has a whole lot of different properties associated with it. And just so you know, I didn't really talk about this, but you can add different data frames. So let's say you wanted to show the entire project like this, but you also wanted to show some detail. You can add a new data frame. And I'm just going to take several of the options here. Let's just take those. I highlighted these layers. I'm just going to right click and copy. And then I'm going to go to my new data frame, right click and paste layers. And so now I'm just going to put my imagery at the bottom. Turn it on. And now I've got a new data frame. And because it's in bold over here, that means it's the active data frame. So that means my navigational tools, like if I right click on Hodiamont neighborhood and zoom to layer, it's going to zoom into that layer. And now with my zoom tool, let's say I wanted to look at Visitation Park, or maybe the area that we were looking at. Let's get the track in there too. So I'm going to right click and copy, then click on the data frame, right click and paste. Now my track is in there. And I'm just going to use my zoom tool to zoom into that area where the line is going around the corner. And now I've got a view of that area also associated with my map. And so you can add multiple data frames. If you wanted to have a data frame for each neighborhood, you could position those around the object as well. And one other thing, under the main map data frame, there's something called extent indicators, which would allow you to indicate where your data frame is. And I'm just going to put a garish green line around it just so we can see it real quick. And so that shows you on the main map where the data frame is located. So you can actually get fairly sophisticated with your layouts. It's just a matter of understanding how to work with this tool. I know you guys have probably spent a lot of time with Illustrator, and Illustrator I'm sure has several bells and whistles that the ArcGIS doesn't. But I would argue that dealing with the spatial data is maybe best done in the GIS, and then export it. Excuse me, export it into an image format that you can then use in Illustrator. Does that did that help? And I know we're 1 minute over time, but I can give you another 4 minutes if you want it.
Okay, who needs more 4 minutes? Who needs extra 4 minutes from Bill? Anybody?
Well, actually, if there are no questions, then let me point something out to you guys in my browser. I'm going to go to gis.woostel.edu. This is the data services homepage. And there's a couple of things to note. First of all, we have a help desk, and this is either Zoom help desk or live help desk. We're actually doing live help desk this semester in Olin Library on level A in the research studio at the times indicated here on this page. So if you need some assistance, you can either come in or you can use the link here to get into the Zoom help desk on these days during these particular hours. And I usually man the desk on Thursdays, but my colleagues on Monday, Tuesday, and Wednesday are also able to help. And they would be, let's see, I'll scroll down, either Jennifer, Doris, or Molly. And so we are here to help. If you guys are encountering problems finding data sets, dealing with ArcGIS, trying to make something happen that you're having trouble with, feel free to contact us through the help desk, or our emails are here, and you can feel free to use my email and contact me directly with questions. I am certainly open to that. Anyway, I hope the session was helpful. If there are no other questions, I will turn you loose.